So hello everyone, today we are going to be talking about functions. So what is a function? So functions basically they are like equations. Okay, let's say you have your equation y is equal to mx plus c, the typical equation of a line that you all know. We are saying that a function y is defined by mx plus c. Okay, so a function, we have what we call a domain. A domain, they are all the ranges of x, or are all our inputs that we put in the function for us to produce the range, which is the output. So the input are values of x. Those are the ones that we just think randomly. I think I should put 2, I think I should put 3, I think I should put 5, and see what my result will be. Okay, so the domain, okay, the domain, which is x, the values of x are the ones that we put in the function for us to get an output, which is y. The output is called the range. So that is basically what a function is. So the element of y assigned to an extent x, to an element x of big X, is called the image of x under f, and is denoted by f of x. So what is happening here is we take a point, let's say we take 2, okay, and then put in a certain equation. 2 is a value of x, and then put in a certain equation to produce y. So what we are saying is the input of x is specific to the output of y, to the output y. The input x, which is the domain, okay, is specific to the output y. So what we mean here is it's only when we put a specific value of x that we get a value of y. So that is what we are typically saying when we say is the image of x under f, which is denoted by f of x. Okay, so we write f for saying f is a function of x plus y, as you can see right here. In this course, both x and y are sets of real number. So for you guys who are doing engineering MTE 101, just know that we are dealing with real numbers of x and y. Your functions will be real functions. Okay, and we usually specify a function by giving an expression f of x. So let's look at examples. You have made these examples. So guys, these are examples of functions. These right here, these are what we call examples of function. Like f of x is equal to 5x to the power 4 plus 9. G of t is equal to 1 minus t cubed. H of s is equal to 9a squared plus 2. Those are examples of function. So you have to understand that in the above examples, the letters, those letters f, g, and h, they are used to denote functions, whereas the letters x, t, and x are used to denote variables. So if you look at the first example, f of x is equal to 5x to the power 4 plus 9. Your domain will be values of x. All the values of x that will be plugging there will be your domain. And then the output, which will be the values of f of x, will be your range. So you have to understand what is the domain, what is the range. Just know the difference. Then a variable is an arbitrary element of a set in the above examples. So the letters x, t, and x denote the independent variables, and f of x, g of t, h of s denote the dependent variables, since their values depend on the values of x. Since I've said that we are taking x is a random value that we are just picking from nowhere. Okay, that is if you are not given the range of x values. So x is just a number that we're just thinking about, and then after we think about, we plug in the function. When we plug it in the function, we'll produce an output y, which those outputs, the groups of all the outputs, they are called the range. Okay, so what we are saying is y depends on what value of x we put in the equation. That is what we mean by f of x, g of x, h of s denote the dependent variables. So f of x depends on x. The value that you are going to put of x is going to determine the value that you are going to get, okay, y, or that you are going to get, which is f of x. Let's say we have taken 3 and it tamii some function and tabudisa kana 12. Saka tiri kuti isusu chaita kuti tibudise 12 inyaya kuti taisa 3, chingade taisa imwe number isiri 3, 12 anga singabudi. Saka tiri kuti isusu 12 uyu ari kudependa nekuti taisa chi, and taisa chi, remember zvatiri kuisa isusu ndo ma x, then zviri kuzobuda ndo value ya f of x, kana kuti ndo usually y, kana value ya g of t, kana value ya h of x. That is what we mean. So the domain of a function f is the largest set of real numbers for which the rule makes sense. Okay, so the domain of f manje, since it's just that domain, more values are x atungofunga randomly tichisa. So it means the domain of x and of f of x, more values akawandisa, in fact all real numbers, we can put them in the domain. Okay, producing a small range y, producing my y values. Each x value corresponds to a y value. So looking at the example 1 over x, we cannot compute f of 0. Why? Because if we put 0 where x is, because what we mean is for us to put, when we say f of 0, we just mean that wherever there is x in the function, replace that x with 0. Okay, so if we are given f of x equal to 1 over x, we mean that if we say f of 0, we mean that that wherever there is x, we put 0. So f of 0 cannot be computed because it becomes 1 over 0, which will then result to something that is not defined. Then the domain of f of x is 1 over x. Is the set of all real numbers except 0. So the domain, what we are just meaning by domain, we mean that all the values of x that we may think of in the real numbers, we can put any value which is in the set of real numbers except for 0, because if we put 0, it becomes undefined. That is what we just mean. So we are given examples of function right there. X is called y is called x squared. Then we are told that our domain is an element of x is an element of x. Then for y is equal to x squared, I think you can see that any value that we plug in there will produce a reasonable output. Okay. So if we put 0, then our output will range from 0 to infinity. Our range. Okay, so I want you to think for a second. Why is it that for our range we have 0 to infinity? Why can't we, since we are putting any value in the function y is equal to x squared, apa tukuti susu apa pana y is equal to x squared apa tungoisa any value yatoda apa domain redu tati susu ma real values ese up from negative infinity to infinity. So my question is, I want you to think, if you can figure this out, then you are smart. Say isusu tina 0 pekutanga pana outputs up. Why do we range from 0 to infinity? Okay, I think you can pause the video and try to think on your own. Okay, so holding your fire, hold your fire. If you are still thinking, hold your fire. All right, so what you need to understand is, each value that we are going to put in under x right there is going to produce a positive y value, because we have a square. We are saying x squared, so it's producing a positive value. That is why the range is, our outputs will be from 0 to the positive infinity, not negative infinity. Okay, so for y is equal to 1 over x, as we have talked about, we cannot put 0 where x is. So 0 cannot be talked about. Okay, so for the domain, we can say from negative infinity to 0, but not including 0, union from 0 to positive infinity. So what we are just saying right there is, for the domain, we cannot put 0. Okay, that is why we have to unite that. So what we just mean is from negative infinity to 0, then from 0 to infinity. 0 is not included there. You need to understand, because if you put 0, it becomes undefined. Then for the range, can we get 0? No. The reason why we have two ranges right there is because we can't necessarily include 0. That is why. So we need to say that our y values will be more than 0 going to negative infinity, and also there will be less than 0 going to negative infinity. There will be more than 0 going to positive infinity. So that is what we mean right there. That is what we are trying to say. Then y is equal to square root of x. So for this, since we want to talk about positive numbers, since we are saying that we are talking about real numbers, why we're talking about real functions, we want our output to be real. So for our output to be real, we cannot put any negative number under x. Where we are supposed to put x, we can't put any negative number. That is why the domain is from 0 to infinity. Then the range is from 0 to infinity also. Okay. So for y is equal to square root of 1 minus x squared, I think since we have a square right there, we can safely say that from negative 1 to 1, okay, all right, okay. So our domain right there, if you look closely right there, our domain is from negative 1 to 1. Our inputs, that is our domain, our values of x. We can't put negative 2 or negative anything that is bigger than 1. Okay, we can't put anything that is bigger than 1, because if we do so, that means that it will become we will have 1 minus a large number under the square root sign, which will produce a complex number, okay, or a complex range. So we don't want that. That is why we range from negative 1 to 1. We cannot also put positive 2 or positive 3 or anything that is more than 1, positive 1, because of the same reason. Because if we put it right there, it will produce a number which is in the negative range, which will then produce a complex number. And we are dealing with real numbers only. Okay. So Well, I want you to try what is there. G of x is equal to x over x squared plus 4x plus 3. What is the domain and range of this function? Okay. So you have to try that. I will work that question with you in just a moment. Okay.